Welcome to the lesson on the Fourth Industrial Revolution. Upon completion of this lesson, learners will be able to define Industry 4.0 and recognize its significance in modern manufacturing, particularly within the context of the electric vehicle industry. They will be able to identify the key technologies driving Industry 4.0. Learners will also be equipped to discuss both the benefits and challenges associated with implementing Industry 4.0 principles in manufacturing processes. Learners will gain practical insights into how Industry 4.0 is transforming automotive production and shaping the future of EV manufacturing. The concept of Industry 4.0 is best understood within the context of the previous industrial revolutions. The first industrial revolution, or Industry 1.0, was characterized by mechanization. This was followed by Industry 2.0, which led to the era of mass production. The third industrial revolution, Industry 3.0, brought automation to the forefront with the integration of computers and electronics into production processes. Now, we're in the midst of Industry 4.0, defined by smart factories and interconnected systems. We will discuss more about the Industrial Revolution timelines in the upcoming slides. To begin, let's look at the first phase of the Industrial Revolution, which is characterized by the advent of mechanization. This period marks the emergence of large-scale mechanical machines powered by steam or water. It began in the late 1700s and in many ways continues to influence us today. What truly defines this era is the use of steam and water power to enhance productivity and facilitate the transportation of products and raw materials to manufacturing sites. This transformation is exemplified by innovations such as the steam engine, as displayed here, and the development of factories along rivers. These factories harness the flow of water to power machinery, significantly boosting efficiency. This advancement accomplished tasks on a scale previously unimaginable. A recurring theme throughout all periods of the Industrial Revolution is how technological advancements and shifts in energy sources have consistently driven productivity. They have expanded the range of what is now achievable, improving both the quality and quantity of the products that are produced. Let's move on to the second second period of the Industrial Revolution, which is mass production. A key feature of this period was the rise of electricity and oil-powered machines in the late 1800s. This ability to offload energy production to coal or electric plants, which might still use water or steam, allowed manufacturing plants to focus solely on housing the machinery needed to produce their product. While we still relied on manpower inside manufacturing plants, with associated safety concerns and productivity issues, small-scale industries were able to grow because they no longer had to worry about producing their own energy. The third phase of the Industrial Revolution is primarily focused on automation. This era began in the late 1960s and continues to evolve today. It is marked by the rapid advancement of electronics and information technology, which allows information to be transmitted more quickly, stored efficiently, and reviewed as needed. Additionally, it enables the centralized housing and management of data. A clear example of this can be seen in dairy farm logistics, as illustrated in this image. With automation, farms can track and manage processes like determining which cows need to be moved to milking stations, scheduling feeding times, and optimizing overall operations. This centralized system facilitates the planning and flow of both information and products, enabling better communication, storage, review, and optimization of processes. Some additional highlights of automation and the changes it has brought include not only the increased use of robotics, but also the replacement of human labor in many tasks. Machines are now capable of producing higher volumes of products in shorter periods of time. Unlike human workers, machines don't experience fatigue and can operate continuously, day and night, with a stable power supply. This ability to run endlessly allows for consistent production with minimal variation and at a much lower cost. As a result, products have become standardized and output rates have significantly increased. However, the rise of automation has also created new demands for maintenance roles. These machines require regular upkeep, refurbishment, and routine inspections to ensure optimal performance. This shift has led to the emergence of specialized jobs focused on maintenance and repair, as well as the need for training programs to equip workers with the necessary skills to manage these duties. Of course, automation comes with some drawbacks. The replacement of production jobs by machines has led to a decline in traditional manufacturing roles. The introduction of automated systems has created a need for new safety regulations. Automated machines often operate without awareness of their surroundings, performing repetitive tasks with precision. As a result, human workers must remain vigilant around these machines, and robust safety protocols are essential to protect workers and ensure the machinery functions as intended. With automation, we also saw the rise of robots, especially in manufacturing. This has now become a key component of automation. We not only have machines that produce parts on assembly lines or through injection molding, but we also have robots that carry out repetitive tasks along these assembly lines. These robots can be pre-programmed with high precision and can perform tasks without user input or feedback. They can be assigned a specific task and repeatedly execute it. Another benefit of robots in manufacturing is their ability to perform hazardous tasks, such as welding in environments with fumes. This protects human workers from health risks. However, early robots lacked sensors and awareness of their environment. They were limited to single tasks and could not adapt to changes in their surroundings. Human operators and maintenance workers were still essential to oversee the robots and address any issues. The Fourth Industrial Revolution, also known as Industry 4.0, represents the fourth major era in manufacturing and industrial development, marking a significant leap forward in how we approach production. At its core, Industry 4.0 is characterized by the integration of advanced digital technologies into industrial processes. This fusion of the digital and physical domains aims to create smarter, more efficient, and highly responsive manufacturing systems. By leveraging technologies such as the Internet of Things, artificial intelligence, and big data analytics, Industry 4.0 is transforming traditional factories into intelligent, interconnected ecosystems. The ultimate goal is to improve productivity and product quality and enable greater flexibility in manufacturing, all while reducing costs and resource consumption. Industry 4.0 is powered by a suite of cutting-edge technologies that work in concert to revolutionize manufacturing processes. At the heart of this transformation is the Internet of Things, abbreviated as IoT, which connects machines, products, and systems, enabling real-time data exchange. This connectivity is complemented by cloud computing, which provides the necessary infrastructure for storing and processing vast amounts of data. Big data analytics turns this data into actionable insights, driving informed decision-making. Artificial intelligence and machine learning take this a step further, enabling systems to learn from data, make predictions, and optimize processes autonomously. Robotics and automation play a critical role in executing these optimized processes, with advanced robots working alongside humans in collaborative environments. Additive manufacturing, or 3D printing, brings flexibility to production, allowing for rapid prototyping and customization. Together, these technologies create a smart, interconnected factory ecosystem that is more efficient, flexible, and responsive than ever before. The implementation of Industry 4.0 principles brings a multitude of benefits to manufacturing processes. It leads to significantly increased productivity and efficiency as smart systems optimize operations in real time. This optimization also results in improved product quality, with advanced sensors and AI-driven quality control minimizing defects. Industry 4.0 technologies enable greater flexibility in production, allowing manufacturers to adapt to changing market demands or customer preferences quickly. Worker safety sees notable improvements too, as dangerous tasks can be automated and smart systems can predict and prevent potential hazards. The ability to customize products on a mass scale is another key advantage, meeting the growing consumer demand for personalized goods. Finally, Industry 4.0 contributes to sustainability efforts by reducing waste and energy consumption through more precise resource management and predictive maintenance. While Industry 4.0 offers numerous benefits, it also presents several significant challenges that organizations must address. One of the primary hurdles is the high initial costs associated with implementing advanced technologies and overhauling existing systems. This financial barrier can be particularly discouraging for small and medium-sized enterprises. As manufacturing becomes increasingly digitized, cybersecurity risks emerge as a critical concern, with the potential for data breaches or system hijacks posing serious threats to operations and intellectual property. The transition to Industry 4.0 also necessitates a workforce with new skills, creating a pressing need for comprehensive training programs and potentially leading to short-term skill gaps. Integrating new technologies with legacy systems presents another challenge, often requiring careful planning and execution to ensure seamless operations. The vast amount of data collected and processed in smart factories also raises important data privacy concerns, requiring companies to navigate legal requirements and implement robust data protection measures. Let us look at some of the case studies of Industry 4.0 implementation in the electric vehicle manufacturing sector. Tesla's Gigafactory stands out with its significant use of robotics in vehicle assembly, complemented by AI-driven quality control and battery optimization systems. They also leverage IoT and data analytics for real-time monitoring and predictive maintenance. BMW's plant Regensburg in Germany takes a different approach, utilizing digital twin technology for virtual factory planning, which allows for precise simulations before physical implementation. They have also integrated collaborative robots, or cobots, to work alongside human employees, improving efficiency while maintaining a human touch in production. BMW also employs AI-powered predictive maintenance system to minimize downtime. Volkswagen's Zwickau factory, dedicated to EV production, similarly emphasizes robotics, including both traditional and collaborative robots. They've also implemented automated guided vehicles, abbreviated as AGVs, for parts transport, streamlining the production flow. Volkswagen further utilizes big data analytics to optimize their supply chain, ensuring smooth operations from raw materials to finished vehicles. The implementation of Industry 4.0 technologies has yielded impressive results across various EV manufacturers. These companies have reported a significant increase in vehicle production capacity, allowing them to meet the growing demand for electric vehicles more efficiently. Substantial reductions in defect rates have been achieved thanks to AI-driven quality control systems and real-time monitoring. The manufacturing processes have become more energy efficient, aligning with the sustainability goals of EV production. Quality control processes have become more accurate, ensuring that each vehicle meets the highest standards before leaving the factory. Notably, there have been improvements in assembly ergonomics and worker safety, demonstrating that Industry 4.0 not only improves production metrics but also contributes to better working conditions. While the specific numbers may vary between manufacturers, these common themes highlight the transformative impact of Industry 4.0 technologies on EV production, setting new standards for efficiency, quality, and workplace safety in the electric vehicle industry. In summary, the Industrial Revolution has progressed through 4 distinct phases, with Industry 4.0 representing the current era where manufacturing merges with AI and smart digital technology for complete automation. This transformation is driven by core technologies, including the Internet of Things, artificial intelligence, robotics, big data analytics, and cloud computing, with major EV manufacturers like Tesla, BMW, and Volkswagen leading the implementation of these advanced manufacturing solutions. Thank you.